Thank you. Hello, everyone. I'm Varuna. I'm a software engineer here at AO.com. Throughout my career, I've worked on building largish enterprise software, both legacy and greenfield. And while I love technical challenges and getting lost in a sea of code, I have a particular interest in the processes around managing software, the processes that help us build the right thing in the right way and at the right time. One thing that has more often than not been an obstacle in achieving this has been legacy code. So let's start by getting a common definition. What is legacy code? Michael Feathers, who has literally written books on the subject, defines legacy code as code without tests. And that kind of makes sense to us. If there are tests around the code, we might feel more confident making changes to it. In theory, the tests tell us what the code should be doing and how our changes might affect the rest of the system. But there's another definition that, to me, seemed to more holistically capture the problem. Dylan Beattie said this at his talk at NDC London this year. He said, legacy code is code that's too scary to update, but too profitable to delete. It doesn't matter if there are tests, no tests, if your code is solid, or if it isn't. If you or your team are too afraid to work with that system, then it's legacy, and something in it likely needs to change. So I worked at this company a few years ago that had these massively popular and financially successful websites in a few different countries. However, these websites were massive monoliths built in web forms, sitting on top of another massive monolith of a web service. And it was painful to make changes to this code base, with even the smallest of changes having unintended consequences across the platform. So us, the development team, we decided we needed to start from scratch, that we needed to build a new website with the latest technologies of the time, and we were going to build it right. It was going to be test-driven and solid and all of this other good stuff. And we did build a new website that admittedly was better structured and cleaner and easier to work with, but there were a few issues with doing this big rewrite. The desire to do a big rewrite sometimes comes from a lack of empathy for the original creators of the software, a kind of lack of understanding that things were done the way they were done for a valid reason that we may not be able to see today. So by doing a big rewrite, we take on the risk of losing years, if not decades, of bug fixes and little features that exist within the legacy software. Then, while we're rewriting, we're no longer innovating in terms of value provided to our customers. We're not building new features, just recreating existing ones, and this could affect our ability to keep or gain new customers. It's also really hard to know what exactly to rebuild. Legacy software, almost by definition, is not easy to understand, and it's therefore even harder to recreate. And so we could end up with this ever-increasing list of features that mean that the rewrite will never be complete. But perhaps most importantly, the big rewrite is a technical solution to a cultural problem. The unwillingness to do the work to learn, understand, and continually improve could mean that every solution needs a rewrite every few years. There are a few companies that have successfully completed these start-from-scratch projects. For instance, Microsoft with Visual Studio Code. But in a lot of these examples, the companies could afford to build and maintain both their old and new systems alongside each other. So how do we tackle this problem of legacy software, but still avoid the big rewrite? We start with smaller rewrites or replacements. So say this is our system with a load of different features floating about. First, we pick a part of the system that we'd like to rewrite. We can make this choice based on 3 factors. How often does the part change? How long does it take to make the change? And how often do the changes result in a bug or some other kind of failure? These measures also give us a good way to make the value and impact of our improvements visible to the wider business. Once we've made this decision, we need to understand what that part does. We can do this by reading the code, of course, and any documentation that exists around it. But we probably also need to talk to the wider business and perhaps even customers to get this understanding. Then we can make the change. We may choose to refactor the part or re-architect the entire system, re-architect the entire part. Here we could create a new service or a few new services that give us the necessary functionality. But most importantly, this gives us the opportunity to add documentation around the code in the form of tests. Once we've done this, we can get rid of the unmanageable legacy code, replacing it with the new code that's just been written. Here, we'll need to build a way to conditionally transfer control from the old system to the new. This could be in the form of redirects or message queues, or simply a connector class or library. Then, if it makes sense to, and only if it makes sense to, we can move on to a different part of the system. There are a few things we need to do as part of this process, however. First, we need to understand that we're currently writing tomorrow's legacy software. So we need to make sure that our code is well tested, but also that it's easy to strangle out and replace in the future. Then there needs to be a little bit of a focus on the culture with regards to building and maintaining software. We need to be willing to have technical debt negotiations with non-technical members of our team. So the next time we're asked to hack a new feature in order to, for instance, be first to market, we're willing and able to explain the consequences of this so the business as a whole can make a decision of whether it's beneficial to take on the technical debt. So to end this today, we've spoken about how the big rewrite is probably not always the best way to tackle legacy software. It's generally better to improve our system part by part. And finally, we need to be mindful of how our decisions today will impact the people who work with our code in the future. Thank you.